Okay, good afternoon, everyone. As Colin said, my name is Naveed Aziz. I'm currently the Vice President Research and Innovation at Genome Canada and also the chair of the Data Working Group for CFI. So I'm in the next probably, I know we have half an hour, but unless you have a lot of questions, we probably don't need it. In the next probably 15 minutes, I'm just going to talk to you a little bit about and report back on some of the things that the working group has been doing and some of the kind of results of the survey that the working group had taken on last year. You all would have received those surveys and filled them out. Thank you very much. So just kind of talk a little bit about that. So is the presentation going to go up at some point? Yeah, I assume it's the big green button, but it's not doing anything. Now I've pressed it 15 times, so probably I'm on my last slide. Okay, right. So while the kind of while we get help on the slides, let me just start a little bit. Oh, here we go. So let me just start a little bit with why does it matter and why we're doing this, right? So Canada has 19 national research facilities that are absolutely critical to our research enterprise. These are not small operations. In 24-25 alone, they served over 17,000 on-site and remote users, and there were 2.2 million data users around the world. When I read that number, I must admit it was mind-boggling. 2.2 million. Paul, you might have a lot to do with this, but anyway, let's move on. And then to put this into perspective, since 1997, CFI has invested nearly $800 million in capital to build these facilities. So that's a massive foundation that CFI invested in. But here's the challenge. When we surveyed our facilities, we found that there were huge gaps in how they manage their data. There's no issues or no questions around the science they're doing or the quality of the science that happens, the world-class science that happens at the facilities. But there was a huge gap around data management, data legacy, data sustainability. So we wanted to dig a bit deeper into that. Um, so CFI had assembled a working group. Names are on the slide here. Most of my colleagues on the working group are here in the room. I'll just take a moment on behalf of CFI to thank all the working group members. Thank you for all your time and effort that you've spent on this. This is critical for CFI, but also for the ecosystem. So thank you for that. And then before I forget, because I will, I also want to thank CFI colleagues, Sarah, Claudia, for supporting and helping the working group in doing a lot of the heavy lifting. We come together, we do a few things, we talk about a few things, and they go away and do all the hard work. So thank you for all of you. And Germa as well for helping us out in all of this. So we had done a high-level survey in 2024, but in 2025, we came back and asked the facilities for more details. We initially essentially had two goals. One, we wanted to know the quality, to quantify their specific data like cycle needs. It was for the next 2 to 5 years. It was not just about we need more storage. It was more about how much storage do you need, what for, how is going to be used. So it was quite a bit of detail that we were asking for. And the second, we wanted to really generate some evidence that could support conversations with other partners, particularly with the Digital Research Alliance of Canada, or DRAC, and ICED, and other partners to make these happen. 18 of the 19 facilities responded to the survey. So thank you very much for all of you who helped us out and responded. Surveys, I never liked them. They take a lot of time. They're essential, but they are pain. So thank you for taking the time. Sometimes I think surveys are more like Nickelback. Like nobody likes them and nobody knows why. So thank you for at least doing that for us. So we concentrate, if you know, you know. So we concentrated on a few areas within the survey, which we thought as a working group were critical areas. And let me just kind of talk a little bit about them one by one, very briefly. So high performance computing, that's the computational power needed for modeling and simulation. We want you to know about cloud computing. Increasingly, facilities are using cloud to handle variable workloads and access to AI and ML capabilities. Data storage, the raw capacity to manage growing data volumes. Software acquisition and development. These are the tools and the platforms that run on the infrastructure. Data product development, taking new and raw data and turning it into useful outputs like dashboards, models, visualization tools, and then other computing hardware, that's networking, power systems, cooling infrastructure, etc. We understand that these are not siloed areas. They're all interconnected. For example, if you want to talk about data storage, you have to talk about and think about cloud strategy. If you want to expand your GPU use, you have to talk about upgrading your power. So they're all kind of interconnected, but also all very important in many ways. So I'm going to just kind of take you through a very high-level summary of these results. I'm told that these slides with all the data will be available to all of you after the workshop, so you can look at things more closely as you wish. So let's start with HPC. Here's what we have right now. 10 of our reported facilities use CPU capabilities. On average, there's about 2,500 cores at these 10 facilities. But the range of these cores is from 20 to 20,000 cores in different facilities. So that's a very huge range how the MSI facilities are operating. I think because some of these facilities are specialized, while others are general purpose. So facilities that do that differently. So it gives you an idea of how the facilities are different, and we can't really just kind of bucket them all together. Same is the situation with GPUs and RAM. The range is very large, and it again shows that the facilities just operate differently. Now, here's what the facilities are telling us what they need. First, modernization of HPC systems. Some of these clusters are aging. These are not obsolete yet, but they're going that way. So facilities really need replacements. Second, reduced wait times. If you're running a large job, you don't want to be waiting many weeks. It's not acceptable at the level of a national facility, and you need better scheduling. Higher storage throughput. The data coming off the modern instrument is enormous. The bottleneck is not often CPUs, but how fast you can take the data and move it to another computer. Then GPU expansion is a big one. Facilities are seeing explosive demand in GPU accelerated AI and machine learning work. This is where modern research is heading, and this is where the needs are heading as well. And finally, flexibility between HPC and cloud and new allocation models. The current mechanisms of sharing national HPC resources are designed for individual researchers. Facilities need something different, and I'll talk a little bit more about that in a minute. On cloud computing, it's an interesting one because this is not something new to the facilities, but it's becoming more essential. As the kind of the need increases in terms of storage and use, cloud is becoming obviously an obvious solution here. But there's nuances to this idea. When you look at scalability and flexibility, facilities want cloud environments where they can spin resources up and down automatically based on demand, because facilities want to auto-scale as they want. When it comes to data sovereignty, that's the most nuanced area. So cloud is global, but Canada has its own data governance requirements. Facilities need to know if their data is going to be physically in Canada. Facilities need to know if they will follow Canadian law, whether the providers will understand Canadian regulations. So it's an important nuance and something that I think most of the people working in kind of the realms of data and data governance are struggling with right now in terms of what's happening geopolitically and how our data needs to be more sovereign. So how do we use these cloud providers while keeping our data more sovereign? The ability of hyperscalers to do certain things and not being able to do certain things. So that's an important piece to think about. Now, this disaster recovery is another thing that we heard from the facilities. If the facilities primary system goes down, research stops. cloud can provide a backup and redundancy in that sense. But AI and machine learning also, cloud platforms are our most advanced AI capabilities live. Facilities are seeing researchers want more cloud native AI. And a hybrid workflow, the reality is that we'll always have on-prem infrastructure. All the facilities will always have on-prem infrastructure because that's required. The infrastructure need to be close to where the data is, or you can need some cloud to integrate smoothly with it. So what's interesting here, what I noted was that while the facility is not asking for everything to be moved to the cloud, but they're really asking a connection to the cloud and cloud to be an option. They're not looking at just let's just use cloud for everything, but they really want to see a combination of two. Well, in terms of data storage, this is where really the scale reality hits. So the facilities are collectively manage 175 petabytes of data today. And to put that into perspective, obviously 1 terabyte, most of you know, is 1,000 terabytes. A high-end laptop these days would have, if you're lucky, will have 1 terabyte of hard disk space. So we're really talking about 175,000 high-end laptops worth of data that's floating around or is within these facilities now. But more interestingly or worryingly, if you want to call it, I should say that a bit quietly, the facilities are projecting that data need to go up to about 45 petabytes by about 45 petabytes in 2 years and over 110 petabytes in 5 years. So that's a 64% increase in the data that's going to be generated by these facilities. When you think about why this explosion is happening, I think the instruments are getting a lot more sensitive. They're generating a lot more data. We are collecting a lot more genomic data, for example. We're collecting a lot more astronomy data, climate data, and all that data adds up. And I think because of that, and then AI, the new technology, is also very data hungry. So data accumulation is going to go at a higher rate. But the challenge is that you can't just add storage. You can't just buy a hard drive and deploy it. You really need a storage architecture. The pie chart here shows you the current distribution of hot, warm, and cold storage. I'm going to skip on what hot, warm, and cold storage mean. I think most of you will either know or can imagine what that means. But the idea here is that we need some architecture. We can't just throw all data in one type of system. You need cold, warm, or hot data systems, and it needs to be tiered with a specific architecture. So we're really asking what really they are asking, or the facilities are asking to support for extreme throughput workloads. Imagine a genomics facility again. Generally, I say genomics because that's my background, but you're generating terabytes of data per day and not having a place where the genomic data can go. So this is the largest kind of single infrastructure need that we have identified, and I think is critical. Software acquisition and development. Software is a different kind of challenge. You just can't buy everything off the shelf, but then again, you can't just build everything for yourself either. So we found that most of the facilities can meet less than half of their software requirements off the shelf, which means that either they are trying to do without it, or they're trying to just build their own, which takes a lot of resource. So it's an important nuance in terms of we need better integration and standardization. We need automation with AI-driven analytics, modern secure software environments, and continued custom developments where workflows cannot be bought off the shelf. And also a shared procurement idea. So some facilities or many of the facilities could potentially be using the same software, but there's no mechanism of shared procurement right now, and every facility is doing it on their own. So there's a huge opportunity for CFI and for others to look into that and see if there's an ability to do combined procurement. The software picture really reveals something important, is the facilities are not looking for a single platform to do everything. They're really looking for better ways to integrate multiple tools, automate manual work, and reduce the burden on custom development. So it's an important area for us to look at and explore further. So in terms of data product development, this one I had to it's mind-boggling for me, even if I as I presented to you, and I've read it and looked at it multiple times. So facilities are currently producing about 4 million data products per year combined. So what are data products? I want you to look a little bit more into this to understand data products are, so think things like dashboards showing real-time research progress, visualization of communication tools, machine learning models, process data that researchers can download. 4 million products a year. That's a huge number. So here's the challenge. These products need to be maintained. You can't just make a product, put it out there, and just forget about it. Facility needs to a scalable pipeline that can handle 4 million updates a year. Again, if you think about it, 4 million different products that need to be updated and taken care of every year. Some of these data products will be important for decades, and some of these data products will be important for sovereignty of Canada. But right now, there is no plan, and the facilities are asked to kind of fend from this for themselves to figure that out. And it's important to look at that. Also, data products need to be accessible by internal teams, external collaborators, and international partners. That's a different infrastructure requirement than just storing these tools. So how do we do that? What's interesting here is that facilities, again, are thinking themselves not just as data collectors, but as service providers. They're producing things of value for the researchers and for the community. And we need to figure out a way to support that activity. And then the last one, I think, is the compute hardware, where power, cooling, network, as I said earlier, these are some of the categories. Again, it's not a trivial to think that these are important categories. It's an unglamorous part of the facility, but it's essential for everything else to really work. So what does all of this cost? We asked you to provide some idea of the costs of in the next 2 to 5 years for data lifecycle. Cost across all categories discussed that I presented to you estimate to be about 70 million for 3 years. And for colleagues, DRAC colleagues, ISED colleagues, this is an important number to look at, and for CFI as well. And about 180, just over $180 million over 5 years. So let me just clarify that a little bit. We asked the facilities to provide these numbers. Some of the facilities really went to town and provide really detailed estimates, and others just ballparked it. So these numbers could be taken with a pinch of salt, but I'm very sure that they are in the right area or the right ballpark for us to be thinking about. So what does this mean strategically? Well, if you look at the numbers, these are fundable. They're not trivial, but it's manageable. When it's also a shared responsibility. So CFI cannot do this alone. The Alliance has resources. ISED has innovation programs. The facilities themselves may have capital budgets that they can pull from other areas, but it requires a coordinated action and commitment from the multiple players. So I mentioned that, DRAC. So how do we solve this, right? Part of the answer involves in a core partnership with the Digital Research Alliance of Canada. The Alliance service is essential to all the facilities and to the ecosystem. Most of what Canada's research community does depend on the Alliance. But here's an honest assessment, and I have David's permission to talk about that. The Alliance was designed to serve individual researchers and research groups. A researcher at a university wants to run a simulation. The Alliance provides compute time, storage, and support. The national research facilities are very different. They are not individual researchers. They are operational infrastructure serving thousands of users. They have 24/7 uptime requirements. They need guaranteed service levels, and they need infrastructure that scales into petabytes. The Alliance has been generous and flexible, but wasn't designed to do this. And we are asking, what would it take to make the Alliance a true partner of our national facilities? And when we look at that, I think first, a guaranteed commercial level of service. The SLAs or the service level agreements that can say that 99% of your data will be available. The response times will be X. This is what all commercial providers will do for you. And this is what DRAX needs to do for the community, and especially for the MSI facilities. Second, a more responsible and flexible allocation. Current allocation models are designed for on annual cycles. Facilities sometimes know that they need a certain burst of resource, be it new instruments or a campaign. Can this system be more responsive? Third, better support for facility-specific workflows. The Alliance supports experts from universities, and they answer their questions individually really well. But the facility managers might have different questions and might need different support. And the Alliance need to get up to speed to make sure that they can provide that support. And fourth, expanded storage and performance. If the Alliance is going to handle the facility's full data infrastructure, they need to grow substantially. And I think they're working on it, and in time they will. So that's good news, but obviously that's something that we need to highlight. So what does partnership look like? The Alliance has to step up and meet some national facilities at scale. And it is really important that CFI and the Alliance work together on this to support all our facilities. So just summing this up, and if my 12-year-old was here, I can hear her say, "Daddy, but what does it all mean?" Well, I'll tell you what it all means, right? Let me step back and tell you what all of that means. Well, first, our national facilities are among Canada's greatest assets. The science happening in these facilities is world-class, but the infrastructure supporting these science has not kept up. We have aging HPC clusters, storage architectures that cannot handle modern data volumes, software that doesn't integrate, and services designed for individual researchers, not operational facilities. The gap is real. We have quantified it. This isn't optional. This is really to stay competitive. Second, here's what the data means, make very crystal clear. No one organization can solve this alone. CFI has the funding and the coordination capacity, but can't build and manage the infrastructure on its own. The Alliance has the national scale, but they were designed for a different user. ISET had the policy levers and innovation funding, and the facility themselves have the domain expertise, along with, of course, with urgent needs. So the solution is what? The solution is a partnership, a genuine coordinated partnership, which each organization plays its role. This is what ongoing discussions will happen now. This is how we're going to look at and see how we can make sure that this coordination and partnership continues. And third, the numbers are not scary. I mentioned this before, and when you look at these numbers, this is potentially around 5% of all of CFI budget over 5 years. So the numbers are not that scary as they sound. They are doable, but has to be done. You can't just assume that this will be done. When you look at other jurisdictions like US and Europe, comparable investment profiles are present in these kind of facilities. And this is my last slide. So what's next for us and what's ongoing? Well, first, we are contributing to the National Academy, Council of Academies, the CCA report on national research infrastructure. This is an independent review happening right now. Our data working group data insights are informing the report, and the report will have credibility and reach beyond CFI. And second, there are ongoing discussions with CFI, between the data group and CFI and the Alliance, to identify some solutions. These are not just one-time conversations, but these are kind of sustained engagements to try and figure out what can be done. So in conclusion, what I meant to emphasize here is that we have done the diagnosis, we have figured out the why, we understand the problem, we've mapped it carefully, we have figured out the what. Now comes the hard part of the how. How do we prioritize? How do we build partnerships? And how do we implement? The facilities are foundational to Canada's research ecosystem. Modernizing these data infrastructure is not an expense, it's an investment in discovery, and how we ensure that the brilliant researchers using these facilities can do their best work. Thank you. Apparently, I'm taking questions. Yes, sir.
Your committee took on this task, and I've got to say, I think you did a fabulous job. You obviously worked super effectively to come out not just with an assessment of the state, but some prescriptions on things that should change. A couple of things that I would have liked to, and maybe I'm sure you've thought about them. One is the 2-year, the 5-year, the short-term solution, but the long-term. At the moment, the informatics work, the computational hardware is being addressed through grant applications.
Yeah.
We do really need a national digital data strategy, a base funding model that ensures these essential resources remain active, alive, and expanding. So that would be the first question. Did your committee look at all at what's happening in other nations? What model can we look at as being super successful in delivering persistent support?
This is, and I'll answer that very quickly, Paul. This is interesting because in the lifetime of the data group, the working group existing, the answer to that question has changed about 3 times. Because the geopolitical situation, just because how AI has kind of rocketed through our lives, from we'll just use Google or AWS. That's our solution.